Hello and welcome back. Example 3 asks, for what values of p greater than 0, so positive p, does the series -1 to the n minus 1 over n to the p converge conditionally and converge absolutely? This kind of series is sometimes called the alternating p series. So something of this form would be an alternating p series. It's alternating, and it's like a p series. It's like a 1 over n to the p. Well, by the alternating series test, that's maybe the first thing that comes to mind when you think about an alternating series. By the alternating series test, this series will converge for all those p-values, all those positive p-values. And the reason is it satisfies the three conditions. One, the terms are, the b sub n's are positive, so this is 1 over n to the p, or the b sub n's. Remember, the b sub n's in the alternating series test are referring to the positive part. If you strip away the alternating part, which is the -1 to the n minus 1, or set it aside at least, the rest of it is the 1 over n to the p, and those are positive. Then we have to say that the terms are non-increasing. In other words, 1 over n plus 1 to the p is less than or equal to 1 over n to the p. So this is b sub n plus 1 is less than or equal to b sub n, in other words. And this is true by inspection. If you make the denominator bigger, denominator, tough word to say, denominator bigger, then the fraction is smaller. That third condition is if you take the limit as n approaches infinity. Well, as long as p is positive, even if it's the 1 over the square root of n, that fraction is still going to go to 0. So even if p is a half power or a smaller fraction, 1 over n to the p will still approach 0. So it looks like by the alternating series test, our series converges, at least conditionally, converges conditionally for some values of p. Let's see where it converges absolutely, though, to figure out which values of p then it must converge conditionally. So if we put the absolute value bars on, that strips away the alternation. So we just get 1 over n to the p. And that's just a regular p series. We know where that converges. That converges when p is greater than 1. Right? It diverges when p is less than or equal to 1. So what we could say, putting this together, well, just that line right there would say that the series, the alternating p series, converges absolutely. It converges with the absolute value bars when p is greater than 1, and otherwise it's going to converge conditionally for all the other p values that are positive. So we can say the series, the original series, don't worry, this ... is not end of problem. This ... is gonna lead to another couple lines. Sometimes the ... dots can be a little scary. So the series converges conditionally for those p values that were between between 0 and 1, and converges absolutely for the p values bigger than 1. So there's where the alternating p series converges conditionally and where it converges absolutely. I think we'll end the video here. Thanks for watching and see you in the next part.